November 20th, 1943. Betio Island, Tarawa Atoll, Gilbert Islands. The sun rises into a white-hot sky, bleaching the lagoon to a sheet of turquoise glass, while powder-fine coral dust rides the wind. Japanese lookouts inside low sand-backed pillboxes press their eyes to rangefinders and field glasses, hearing the metallic thud of distant ship guns roll in like thunder, and smelling the mix of oil, hot salt, and cordite. They are certain of the reef, a ragged coral lip hundreds of yards from shore, where any American boats will grind to a halt, forcing infantry to wade under overlapping arcs of machine gun and anti-boat fire. For months, Sasebo Special Naval Landing Force men have stacked timber, poured concrete, and sighted guns into the shallows. The plan is simple and deadly. Stop them at the reef and cut them down in the water. Then the first shapes break the lagoon's chop, boxy hulls riding low, not boats but tracked machines that churn forward where the reef should have been safety. Amtracs LVTs clatter over coral heads at roughly 6 knots in the water, their 26-foot hulls nosing up and crawling where even a shallow-draft landing craft would stick. Some are gun-turreted amphibious variants, spitting 37mm bursts. Others are troop carriers packed tight with Marines, 14 to 18 men braced behind cargo coamings, faces slick with spray. Barbed wire rips and disappears under steel cleats. Seawalls that were meant to stall men on foot become ramps for tracks. The defense scheme, Reef waterline sand, collapses in minutes. Inside the vehicles, Marines cough through exhaust and salt, knuckles white on rifles as the hulls slam from sea to sand. Onshore, Japanese gunners shift fire frantically, disbelief rising with the smoke as the impossible keeps coming. More LVTs, more silhouettes, more sand kicked up by tracks. By late 1943, the United States had already produced these amphibious tractors in the thousands. But here on Betio, their purpose becomes undeniable. No tide, trench, or reef can keep them out. The question of how such machines were imagined and built does not begin in the Central Pacific. It begins years earlier, far from any reef in quiet American workshops, and proving grounds that turned a rescue craft into an assault doctrine. September 1935, Palm Beach County, Florida. The eye of the Labor Day hurricane had passed, but its fury lingered in miles of drowned marsh and broken causeways. Amid the wreckage, inventor Donald Roebling surveyed a landscape where boats could not go and trucks could not roll. The grandson of the man who built the Brooklyn Bridge, Roebling watched rescuers struggle to reach the stranded and conceived a solution. A vehicle that could crawl through water and mud alike. By 1937, his alligator prototype emerged, a low box-like craft riding on endless tracks of cleated metal, powered by a 92-horsepower Chrysler engine. It could carry a ton of cargo, float on its aluminum hull, and climb over obstacles half its height. Built for saving lives, not taking them, it was a marvel of practical engineering born from disaster. News of the alligator reached the U.S. Marine Corps at Quantico, Virginia, where amphibious warfare thinkers were quietly preparing for wars that might begin on distant beaches. To officers studying Japan's island campaigns in China and Manchuria, Roebling's design looked like the missing link between ship and shore. In 1938, the Marines persuaded him to adapt his alligator for military use. Trials began at Quantico's muddy Potomac flats, tests that astonished observers when the ungainly craft powered up steep riverbanks and plowed through tidal muck where no landing boat could go. The Marine Corps saw what others did not just a rescue vehicle, but a future amphibious assault machine. When global war loomed in 1941, Roebling's design was militarized and renamed. The landing vehicle tracked. The LVT-1 could carry 18 men or 4,500 pounds of cargo at roughly 7 miles per hour on land and 6 in calm seas. It was crude, unarmored, open-topped, but it worked. By the time Pearl Harbor was attacked, the Marine Corps had ordered hundreds, soon thousands. The Japanese, who had once led the world in amphibious tactics, paid little attention. They assumed the Americans still relied on wooden landing craft, easily stopped by reefs and machine guns. Yet as the U.S. Navy's island-hopping strategy began to form, engineers refined Roebling's concept, adding armor, heavier armament, and ramps that turned the alligator into a weapon. By 1942, the LVT was no longer an experiment but a cornerstone of a new doctrine, that the sea itself could become a highway for invasion. Ahead lay Guadalcanal, Tarawa and Saipan, tests that would decide whether Roebling's storm-born machine could turn the tide of the Pacific War. Early 1940s, American engineering shops and naval proving grounds hum with adaptation. Turning Roebling's Alligator into a combat vehicle required structural, mechanical and ballistic changes. The Food Machinery Corporation, FMC, swapped the thin aluminum hull for armored steel plating, fitted self-sealing fuel tanks to reduce fire risk, and redesigned internal stowage to carry ammunition and communications gear. Power leapt forward. The LVT-2 water buffalo, introduced in 1942, used a 262-horsepower Continental W670 radial engine, replacing Roebling's automobile-derived motor. The result was greater speed, sustained torque for surf runs, and improved reliability under saltwater stress. Tracks and flotation were rethought. Engineers widened cleated treads and adjusted suspension, so the vehicle sustained traction over coral heads and soft beaches. Hull contours were lengthened and ramped to increase buoyancy and make nosing onto sand smoother. Weapons were added for suppression. Pintle-mounted Browning 30 caliber and 50 caliber machine guns became standard on many troop carriers, while the LVT-A1 variant mounted a 37mm gun in a rotating turret, bringing direct armored fire to the final yards ashore. Survivability features, bilge pumps, armored engine decks and compartmentalized fuel cells cut losses when craft were hit and reduced catastrophic fires that earlier designs suffered. In trials, these upgraded LVTs routinely climbed steep berms and negotiated obstacles that had stopped conventional landing craft. Contemporary test reports recorded short bursts of beach climb at gradients approaching 60 degrees. FMC production expanded rapidly. By 1943, thousands of LVTs and specialized variants were rolling off assembly lines, shifting the balance between sea and shore. From the Japanese perspective, who expected slow, unarmored Higgins boats, the idea of tracked armed vehicles debouching under fire was disorienting. Design teams continued incremental upgrades through 1944 and into 1945. The technical evolution was effectively complete in time. For the first true operational trial, the Reef at Tarawa would be the crucible that proved whether these machines could change the rhythm of invasion. Across the scattered chains of the Central Pacific, nature itself seemed to conspire against invasion. Coral reefs, jagged, bright and deceptively shallow, fringed nearly every atoll, forming a natural fortress that could slice through hulls or trap landing craft hundreds of yards from the beaches. In places, these reefs rose just below the surface, sharp as broken glass, stretching into lagoons of knee-deep water where the tide obeyed no schedule familiar to men or machines. The Japanese, veterans of their own amphibious operations in China and Southeast Asia, studied these reefs with professional admiration. They saw in them a perfect ally, one that required no ammunition, no reinforcement, and no rest. Their engineers built accordingly. At Tarawa, they covered the lagoon with wooden stakes, mines, and barbed wire, while concrete bunkers and coral pillboxes guarded every approach. Rear Admiral Keiji Shibasaki, a confident and capable officer, declared that 1,000,000 men couldn't take Tarawa in 100 years. From the waterline inward, his defenses were layered for slaughter. Yet faraway American planners were looking down from the skies. Aerial reconnaissance photographs from B-24s revealed the precise contours of Tarawa's reefs and the deceptive shallows that could doom an amphibious fleet. Reports warned that even the Navy's new Higgins boats, flat-bottomed, propeller-driven LCIs and LCVPs, would almost certainly ground out before reaching the beach. The tide charts confirmed the risk. The lagoon at Betio was too shallow except at rare high tides. A failed landing could mean thousands lost before a single man reached the seawall. There was, as the planners concluded, only one hope: the tracked amphibians. So the Marines loaded 125 LVTs onto transports bound for the Gilberts. Many were fresh from factory floors, their paint barely dry, their crews barely trained, but they were the only machines that could swim over coral and keep moving. On the morning of November 20th, 1943, as the tide stubbornly refused to rise, the Higgins boats indeed struck the reef and stopped cold, targets for machine guns. The Amtracs, however, kept going, crawling past the stranded craft. their tracks grinding over coral heads that had defeated every landing craft before them. It was the moment when the geography of the Pacific, once Japan's shield, became its undoing. The Reef no longer ruled the invasion. American engineering did. The next challenge would be to hold the beach itself, where hundreds of guns still waited. November 20th, 1943, Betio Island, Tarawa Atoll. The sea glowed orange beneath the rising sun, slick with oil from the naval bombardment that had pounded the island for 3 straight hours. At exactly 9 a.m., the guns aboard the battleships Maryland and Colorado fell silent. Smoke curled above the flattened palms, and for a heartbeat there was quiet. Then out on the lagoon the sound of engines rose, a low mechanical growl building into a roar as rows of LVT-1s and LVT-2s churned forward in formation. From the decks of Japanese bunkers, soldiers of the 3rd Special Naval Landing Force stared through firing slits, unsure of what they were seeing. The enemy was supposed to wade through the reef, not ride over it. Yet the machines kept coming, their cleated tracks flinging white spray, their box-like hulls crawling through water that had stopped every previous invasion. As the range closed, the Japanese gunners opened fire. 13mm heavy machine guns, 75mm coastal artillery, and anti-boat guns raked the surf. Explosions threw geysers of coral and blood into the air. LVTs vanished in sheets of flame, their hulls torn open like tin cans. Some Marines inside were killed before they ever saw the shore. Others leapt from burning vehicles to wade the final yards through boiling shallows. Yet most of the Amtracs kept moving, driving over the reef and through the smoke, pushing through terrain that had been mathematically calculated to kill them. When the first LVTs slammed onto Betio's sand, they opened their hatches and disgorged Marines directly into the line of fire. Muzzle flashes erupted as men fanned out from the steel hulls, grenades arcing toward pillboxes that moments earlier had seemed untouchable. Inside the Japanese defenses, panic replaced confidence. The carefully plotted interlocking fields of fire broke apart as gunners swiveled wildly to engage targets now attacking from unexpected angles. The 1,000,000 men in 100 years' defense had lasted less than an hour. Still, the price was staggering. More than 1,000 Marines would die in 3 days of fighting, many within sight of the tide line. But the meaning of Tarawa was larger than its cost. For the first time, tracked amphibious armor had carried men across a reefed lagoon and straight into combat, proving that geography no longer dictated battle. Across the Pacific, commanders studying the after-action reports understood what Tarawa had revealed. The LVT was no longer a novelty. It was the spearhead of a new kind of amphibious war, one that would roll relentlessly across the islands to come. The silence after Tarawa was not peace, it was disbelief. Across the scattered Japanese garrisons of the Central Pacific, word spread through coded reports and stunned testimony. From the few survivors of Betio, officers described vehicles that swam like boats but climbed like tanks, machines that defied both the sea and the defenses designed to command it. At Rabaul, analysts in the 8th Area Army pored over fragmentary intelligence and sketches drawn from memory. At Truck Lagoon, naval engineers examined twisted steel pieces salvaged from the lagoon floor, remnants of LVT hulls shattered but not sunk. Their conclusion was grim. The Americans had built something that rendered the reef barrier, the cornerstone of Japanese island defense, nearly useless. These cannot be stopped in shallow water, one technical report noted. The Imperial Army had no equivalent. Its Daihatsu landing craft, though reliable, was slow, flat-bottomed, and helpless against obstacles or crossfire once grounded. Doctrines that had once seemed elegant, anchored in overlapping fields of fire. Trenches and reef-based delay now appeared obsolete. In the months after Tarawa, Japanese diaries from the Marshall's campaign recorded a creeping fear. "We fired until the barrels smoked," one soldier wrote at Kwajalein. But the monsters kept coming, breaking wire and climbing, over the sand wall as if the sea itself carried them. Panic rippled through coastal defense units when counterattacks failed to stop these tracked invaders before they poured more Marines onto the beaches. Garrison morale, once sustained by the certainty of geography, began to erode. For the Americans, the same spectacle became legend. Newsreels and field reports celebrated the LVT as a symbol of invention and persistence, proof that engineering could outthink nature. Across the Pacific, Japanese commanders adjusted their maps and their expectations. From this point forward, the enemy no longer planned for tides and reefs. They planned for the machines that could rise from them. The victory at Tarawa ignited a demand that only American industry could answer. Within weeks, the U.S. Marine Corps issued orders for thousands more LVTs, recognizing that these strange track-borne craft had become as essential to amphibious war as rifles or artillery. The Food Machinery Corporation, original builder of the earliest alligators, now worked alongside Borg Warner, Ingersoll Steel, Graham Page, and St. Louis Car Company. Their assembly lines, once built for tractors and civilian machinery, were retooled to turn out armored hulls by the hundreds. Between 1942 and 1945, more than 18,000 LVTs of all types would roll off American production floors. Each required nearly 5 tons of steel, complex track assemblies, and hundreds of specialized parts supplied by a logistics network stretching from the foundries of Detroit to the docks of San Diego. Refinements appeared almost as quickly as the vehicles themselves. The LVT-4 introduced a rear loading ramp, eliminating the need for Marines to clamber over the sides under fire. This single change cut unloading times to seconds and allowed heavier cargo, jeeps, howitzers, even field kitchens to roll directly onto the beach. The LVTA-4 replaced its smaller gun with a turreted 75mm howitzer, transforming it from a transporter into a direct-fire assault vehicle capable of smashing pillboxes before infantry landed. In parallel, training centers like Camp Pendleton in California and New River in North Carolina began producing entire amphibious tractor battalions. Recruits drilled in loading, navigation, and beach landings until the Amtrac became second nature, a machine that could be trusted as both transport and shield. While American factories glowed through the night, Japan's industrial base was faltering. Air raids, material shortages, and fragmented production meant no comparable amphibious vehicle ever emerged. By 1944, the United States could launch entire fleets of LVTs for a single operation, rows of steel beasts that guaranteed no reef, tide, or trench would ever again halt an American landing. January 31, 1944, Kwajalein Atoll, Marshall Islands. Dawn revealed a lagoon whipped white by wind and smoke. From the decks of American transports, the sea appeared alive. Hundreds of LVT-4s advancing in staggered waves, their tracks biting through coral heads, invisible beneath the turquoise water. The lessons of Tarawa were etched into every order, every formation. Naval bombardment was timed to the minute. Pre-landing reconnaissance had charted every reef, and the Marines now trusted their machines implicitly. The LVT-4s, with their new rear ramps, carried men and supplies directly through the surf, unloading under fire with practiced precision. As they reached the beach, tanks and artillery followed through the lanes they had cleared, turning chaos into a calculated rhythm of advance. Within hours, strong points that might once have resisted for days were burning ruins. For the first time, the Marines had conquered a fortified atoll without catastrophic loss, a triumph of adaptation and coordination as much as courage. 5 months later, on June 15, 1944, the concept reached full maturity at Saipan. Nearly 700 LVTs, ranging from troop carriers to gun variants, led the assault through heavy surf and shellfire. Some had been modified with rocket launchers and flamethrowers, capable of setting entire bunker lines ablaze before the infantry even landed. The Japanese defenders of the 43rd Division had prepared overlapping coastal batteries, confident they could replicate Tarawa's slaughter. Yet their shells often splashed harmlessly into the water as the Amtracs changed direction mid-lagoon, presenting constantly shifting targets. The sight of armored vehicles swimming toward shore, immune to reefs and relentless in movement, shattered morale before the Marines even reached land. Kwajalein and Saipan proved what Tarawa had only suggested, that the LVT was not an experiment, but a doctrine. It had become an amphibious spearhead, an extension of marine infantry itself, merging sea and land into a single field of battle. Each new island seized shortened Japan's defensive arc, each wave of Amtracs tightening the noose. What began as a rescue craft in Florida's swamps had now become the mechanical heartbeat of the Pacific advance. By late 1944, a strange new fear haunted the Japanese garrisons scattered across the Pacific. the fear of the sea itself. Once viewed as their natural ally and moat of protection, the ocean had turned traitor. After Tarawa, Kwajalein and Saipan, intelligence officers began reporting the same phrase from outposts, beasts that crawl from the ocean. To defenders on coral atolls, the horizon no longer promised distance or safety. It promised an approaching roar of engines, a line of metal creatures rising from the waves. Some units dug secondary trenches near lagoons instead of facing the open sea, convinced that the next attack would come from any direction the tide allowed. Others wired coral ridges with explosives, hoping to collapse them as barriers, only to see the LVTs climb over, churn through, and keep coming. The psychological toll was immense. The LVT's ability to appear unstoppable, climbing reefs, crossing surf, and spitting fire as it came ashore, shattered the defensive logic on which Japan's island garrisons depended. At Tinian, Japanese soldiers wrote of firing rifles and light machine guns point-blank at oncoming Amtracs, watching bullets ricochet off armored plates before being engulfed in returning fire. The effect was more than tactical. It was existential. For the Marines, the Amtrac became a symbol of salvation, a trusted vessel that could carry them through hell to dry land. For the Japanese, it became an omen of defeat, proof that even nature's barriers could no longer protect them. This shift eroded morale across the island chain. Counterattacks that once began with shouted confidence now faltered as men hesitated, certain that the first wave of swimming tanks meant the end was near. The LVT had done more than carry troops. It had changed the psychology of war itself. By transforming the sea into an instrument of invasion, it stripped Japan of the illusion that any place, however remote, could remain beyond reach. By the final months of 1944, the landing vehicle tracked was no longer just a machine. It was doctrine made flesh and steel. The US military had absorbed the hard lessons of Tarawa, refined them through Kwajalein and Saipan, and forged a new amphibious science. At Peleliu that September, waves of LVTA-4s led the assault under the glare of a merciless tropical sun. Their 75mm howitzers, mounted in open turrets, fired high-arc shells over the heads of advancing infantry, smashing pillboxes and trench systems before the first Marines even set foot ashore. Behind them came ranks of LVT-4s laden with troops, ammunition and rations, rolling directly through surf where landing craft dared not go. The battlefield now moved in layers. Naval gunfire pounded the beaches. LVTs carried the assault through the shallows, tanks followed in their wake, and infantry secured the ground they delivered. At Leyte in October, the same method unfolded on an even grander scale. Hundreds of LVTs hit the Philippine beaches in a perfectly timed ballet of movement and firepower. The 1st Cavalry and 7th Infantry Divisions advanced as if choreographed with the tides, each Amtrac wave guided by radio coordination between ships and shore. To Japanese defenders, watching through rangefinders from mangrove lines, it seemed unnatural. Amphibious tanks that move as one with the sea, one observer recorded. Machine gun fire rippled across the water, but the armored waves kept forming, kept coming. An industrial tide given purpose. This precision was the culmination of years of trial, loss, and adaptation. The LVT had evolved from a rescue craft into the centerpiece of amphibious warfare, turning geography itself into a controllable variable. Landings that once consumed days now secured their objectives in hours. By the dawn of 1945, as the Pacific Campaign closed in on Okinawa, the Amtrac stood ready for its final, fiercest test, a war machine that had mastered both land and sea. April 1st, 1945, Easter Sunday, Okinawa. The sea was grey and heaving under a low mist as the largest amphibious armada of the Pacific War assembled just offshore. Over 200 LVTs floated in formation, engines rumbling like distant thunder, their armored hulls packed with US Marines and Army infantrymen bound for the beaches of Hagushi. For the men aboard, the horizon was a line of smoke and fire, the final gateway to Japan itself. At 8:30 a.m. the order came, advance. The first waves of Amtracs surged forward through the churning surf, their tracks cutting white scars across the water. Behind them, the gunships of Task Force 58 unleashed a continuous bombardment that made the island tremble. Unlike Tarawa or Saipan, Okinawa was not a reefed fortress, but a vast and living battlefield. Hidden artillery, cave systems, and ridgelines turned every approach into a death trap. Yet the LVTs proved again their worth. They crawled over shallows, through tide flats and mud, carrying their human cargo beyond the reach of the reefs that had once dictated fate. On the beaches, Marines spilled from the ramps under sniper and mortar fire, pushing inland while LVT-A4s with 75mm howitzers laid covering fire. Some Amtracs burned before reaching shore. Others sank in the swell, riddled with shells. Still, the formation never broke. Supply convoys followed in their wake. Food, fuel, ammunition, all ferried ashore by the same amphibious fleet that had begun its journey years earlier as Roebling's experimental rescue craft. For the Japanese, Okinawa was the last desperate stand. They launched night counterattacks, suicide charges, and artillery barrages that battered the landing zones without halting the relentless mechanized tide. For the first time, LVTs worked in tandem with Sherman tanks and flamethrower vehicles in sustained ground combat, serving as mobile supply lifelines and fire platforms. Many were destroyed, but their sacrifice ensured the advance never stalled. When the battle ended after 82 brutal days, the LVT's legacy was unshakable. It had evolved from invention to instrument of victory. As Japan's ocean walls crumbled, these amphibious beasts became the enduring emblem of Allied persistence, and proof that even the sea could be conquered by human design. For all its triumphs, the landing vehicle tract was no miracle of invulnerability. Its earliest incarnations, the LVT-1s that stormed Tarawa, were little more than open tubs of steel, unarmored and exposed. Machine gun bullets and shrapnel ripped through their thin hulls with ease, and their crews fought half-submerged, drenched in salt spray and smoke. Mechanical failures were frequent. Engines overheated, transmissions jammed in sand, and saltwater corroded wiring in days. During the Tarawa landings alone, more than one-third of all Amtracs committed were destroyed or disabled. Some sunk by direct hits, others simply stranded with seized gearboxes or torn tracks. Even later models, armored and armed, remained vulnerable to artillery, mines, and the grinding exhaustion of prolonged combat operations. But every weakness became a lesson. Field workshops sprang up on beaches, where mechanics worked knee-deep in mud to strip wrecks for usable parts and rebuild engines under fire. Maintenance crews learned to waterproof radios with grease and canvas, while Marines developed an intricate vocabulary of hand signals when static or salt ruined communication. Engineers back home listened closely. Armor plates were thickened, suspensions strengthened, and self-sealing fuel tanks became standard. The LVT-4's rear ramp was not just a convenience. It was born from the blood of men trapped under fire, trying to climb over earlier models' sides. The Japanese tried to adapt as well, building coral log barriers and seeding beaches with explosive traps, but their efforts were piecemeal and reactive. No countermeasure could match the American combination of industrial flexibility and field ingenuity. In every campaign, the Marines and their machines grew more efficient, more synchronized, more unstoppable. The LVT's flaws had not diminished its legend. They had defined its evolution. In the end, it stood as the embodiment of the American method of war, learning faster, adapting under fire, and refusing to yield terrain to either man or nature. When the guns finally fell silent in 1945, the sea once again became calm, but the ideas forged upon it endured. The landing vehicle tracked, born from a hurricane rescue craft and hardened in the Pacific's fire, had changed how armies thought about coastlines forever. The U.S. Navy and Marine Corps, unwilling to lose the advantage it had given them, retained large numbers of surviving LVTs after the war. Workshops and depots across California and Okinawa began rebuilding and redesigning them for a new era, adding armor, enclosed cabins, and more powerful engines. By the early 1950s, the lineage evolved into the LVT-P5, larger, faster, and capable of carrying 40 fully equipped Marines. Amphibious operations were no longer seen as desperate improvisations. They were a permanent arm of military doctrine, grounded in the lessons the Amtrac had written in salt and blood. Other nations watched closely. British and French engineers dissected captured or loaned LVTs to study their balance between buoyancy and traction. Even Japan, whose soldiers had once stared in terror at these machines rising from the sea, incorporated the concept into its post-war self-defense forces under American guidance. The Soviet Union developed its own tracked amphibians, recognizing that future conflicts in Asia or Europe might demand the same dual-terrain agility. The Cold War only deepened the relevance of the design. From Korea's tidal flats to Vietnam's river deltas, the LVT's descendants continued to prove that mastery of the littoral zone, the uncertain boundary between water and land, was as vital as any air or ground superiority. In the end, the legacy of the LVT was not merely mechanical, but philosophical. It demonstrated that innovation, adaptability, and bold design could break what once seemed unbreakable. The moment on Tarawa's Reef, when steel crawled over coral and into history, redefined warfare at the water's edge, and the echoes of that revelation would ripple through every amphibious doctrine for generations to come. The story ends where it began, on the reef at Tarawa, that pale, jagged barrier stretching beneath the still Pacific sun. The surf still breaks over the coral, and the lagoon still glows turquoise in the morning light, but its purpose has long since changed. Once, this reef was the line that Japan believed no enemy could cross, a natural fortress meant to grind steel and drown men. Now, beneath those same waters, rest the rusting hulks of Amtracs and the remains of Marines who rode them into history. The sea that was supposed to protect an empire instead carried its undoing. For the Japanese defenders who once watched in disbelief as the LVTs crawled from the waves, Tarawa became a caution etched in memory, a lesson that technology could outpace faith and that preparation could crumble before invention. For the Marines, it became something else entirely, a testament to the power of courage joined with creativity, proof that no obstacle, no matter how immutable it seemed, could stand against the will to adapt. The reef that once symbolized defense became a monument to transformation. It marked the moment when war left behind the limitations of terrain and embraced the boundless reach of human ingenuity. In every amphibious landing that followed, from Okinawa to Korea to far later shores, the imprint of those first steel tracks endured, a reminder that even nature's strongest walls can fall when imagination dares to meet them head-on.